In this example, we are going to see another example of prompt engineering. We're going to start with a blank Canva and we're going to try to have our model behave differently based on the different intent of the user. A different prompt is going to be triggered from the model understanding what is the user wanting to talk about. So in the example that we are going to create, we are going to be using a multi-prompt chain. So remember, we always start with chain. We are going to drag and drop a multi-prompt chain. A multi-prompt chain is going to allow us to use multiple prompt templates or multiple prompts with a single chain or with a single LLM chain. So we need a language model like we always do. So we are going to add a chat model. In this example, we are going to add a chat OpenAI chat model, and we're going to connect it to the language model. We can also use a LLM model, but in this example, we're going to use a chat model. We are going to add our API key. And that's going to be it. We are going to lower the temperature from 0.9 to 0.7. And now we're going to insert our different prompt templates. The next step is going to be to add a prompt retriever template. So to do that, we can either go to retrievers or we can search for it in the search nodes. So in the retrievers, we can see that we have a vector store retriever and a prompt retriever. We're going to use a few of these prompt retrievers. So what we're going to be building is we're going to be building a chat conversation with a large language model that is going to understand about what kind of topic we want answers. If we're talking about physics, if we're talking about math, about history, and based on our intent or based on the topic, it is going to generate a different output or a different response format so that we know that we can have it behave differently with different syntax or different context. So let's add one more of these so that we can have 3 of these. We're going to connect each one of them. We're going to connect it to the prompt retriever. And now that all 3 of them are connected, we can create our prompts. Let's connect this final one. Here we go. So the first one, we are going to call it physics. This one, we are going to call it math. And the final one, we are going to call it history. In the prompt description, we are going to write something like good for answering questions about physics, and in the math one, good for answering questions about math and history. Now, you can be as specific as you want with these and customize them to your needs. Now, in this, also in the prompt system message, this is what we are going to be asking the large language model to do. So, for example, you are a very smart physics professor. You are great at answering questions about physics in a concise and easy to understand manner. When you don't know the answer to a question, you admit that you don't know. You will answer like this. So the answer we are expecting should be structured with physics and then 2 dots so that we know that we are actually accessing this prompt. And then your answer, and you will answer, always try to output your answer as a table in HTML. So the answer should start with physics and there should be a HTML table when we talk about something like physics, like if we ask a question about gravity or about Newton or about any other physics related subject. Now we're going to do the same with math, and let's check out the prompt for math. You are a very good mathematician, you're good at answering math questions, but in this example we are not going to tell it to write physics or math. So we're going to leave it differently so that we can find we can see the difference between the different answers and how we are controlling the output of the large language model. And now for history, also we are going to say pretty much the same thing, and also we're going to add this. So if a question is about history, we're going to add history XX and also provide a HTML table if it's possible about the answer. Now that all of that is done, we can try our conversation. We have to save our chat flow, and we're going to call this prompt retriever chain. Once it's saved, we can test it out and we can ask it about tell me all the tanks from World War II. So if this is, if it's understanding that it should use the prompt of history, so it has identified, and the answer that it's providing is starting with history XXX, and it is giving me a short description and then the table that I have asked it to create with the different tanks from the different countries. Now I haven't specified anything else, but I can be as specific here as I want to customize the output however I want. Now let's try something else. Tell me about temperature changes in liquids, something that is related to physics. Let's see what it is. My question is relatively general, so it understood that we are talking about physics, and it's also creating a table like I have asked and giving a explanation. So it is meaning that it is accessing our prompt, and what this means overall is that we can create a conversation and we can guide the large language model to answer however we want based on the intent or the topic that the user is understanding. We don't have to train our chat to understand what the user is talking about. The model will understand and it will ask the correct prompt retriever to with the correct prompt to generate the right answers. This is very important in prompt engineering, so I do advise you to experiment with this and the previous examples so that you make sure that you understand this concept. Thank you so much for watching, and I will see you in the next video.